My name is Megan Winterberry, and I did my project on biopolymers in textiles. Biopolymers are natural polymers produced by the cells of living organisms. Like other polymers, they consist of long repeating chains of molecules. Research is currently being conducted on biopolymers as a possible alternative to conventional textile fabrics, as they are a renewable source, usually non-toxic and biodegradable. In my experiment, the base of my biopolymer is alginate, which is derived from seaweed. These are the materials that I'll be using for my experiment. First, I measured out 5 grams of sodium alginate, which is extracted from brown seaweed. This is the base of the biofabric. In the textile industry, it would replace synthetic fibers that use harmful chemicals and contribute to the emission of greenhouse gases. I then added 200 milliliters of water to the powder. Next, I blended it until all of the powder was dissolved and it starts to become thick and a similar consistency to jelly. Next, I'm adding 8 grams of glycerin, which is a non-toxic ingredient commonly added to polymers to make it smooth and more flexible. I'll be testing 3 different amounts of glycerin to see how it changes the properties of the biofabric. Next, I blended the mixture again. I then poured the mixture into a cup and put it in the fridge overnight to get rid of all of the bubbles. Next, I am repeating those same steps over again by putting 5 grams of sodium alginate into 200 milliliters of water. And I blended that again until it is fully mixed. This time I only added 4 grams of glycerin instead of 8 that I did last time. And then I blended that again. I do this one more time with, once again, the 5 grams of sodium alginate into the 200 milliliters of water. I blend it again, and this time I don't put any glycerin into it. I then labeled all of the cups with the amounts of glycerin in them and put them in the fridge overnight. Now I'm going to make a calcium chloride solution to cover the surface of the alginate mixture. I mixed 10 grams of calcium chloride with 100 milliliters of water to make a 10% calcium chloride solution. I then pour it into a spray bottle. To make my mold, I took a piece of fabric and placed it on an embroidery hoop, and this is going to be the mold for my biofabric. I sprayed the calcium chloride solution on the fabric, fully covering it. I then pour my 8 grams of glycerin alginate mixture onto the mold. And then I smooth it out so that the mixture is touching all of the sides of the embroidery hoop. Next, I spray more of the calcium chloride solution on top of the mixture. Now I do the same thing with the 4 grams of glycerin alginate mixture. And then I will spray the calcium chloride solution on top of that. Now I do it one more time for the alginate mixture with 0 grams of glycerin in it. And then I pour it into the mold. And then I also spray the calcium chloride solution onto that as well. This is the result of the 8-gram mixture, and as you can see, it's pretty strong and flexible. This is what turned out the best. This is the 4-gram solution, and it feels most like an actual fabric and is also strong and flexible. The one with 0 grams of glycerin fabric felt a lot more like jelly and wasn't as strong, but was still flexible. In conclusion, the alginate mixture with 4 grams of glycerin was the strongest and most flexible, and it imitated a normal fabric the most accurately. Biopolymers can aid in different textile processes such as fiber production, treatment, and finishing, while being cheap to produce and environmentally friendly. Thank you.